Hello everyone. Today we are going to start the new topic, that is the heat transfer and few terminologies related to that as well as the laws related to that. Okay. So first we must understand what is meant by heat transfer. Heat transfer is a discipline of a thermal engineering that concerns the generation, use, conversion and exchange of the thermal energy between the physical system. So let's say you can see here in the example, there is a pan containing water, and that pan is also having the handle which someone is holding, that person is holding, and below it a fire is going on. Okay. So what is going to happen here? There are basically three modes of heat transfer is there. Okay. Before going to the modes of heat transfer, let me tell you one thing. What is going to happen in the fire? There is a heat generation due to the burning of the fuel. Okay. Or you can say chemical energy is converting into the heat energy over there. Then that energy is basically transferring toward the pan. That means that pan is actually exchanging the heat. Okay. So you can see here there is a transfer of heat from one place to the another place, as well as you can see in this fire there is a generation of the heat, and that heat is basically used to boil this water. Okay, so you can see these all phenomena are used over here, that is generation, use of that heat, conversion of heat and exchanging that heat. Okay, so this all phenomenon is related to the transfer of the heat. Okay, how much heat is transferring? So we can say that heat transfer is a branch of the thermal engineering which concerns with the generation of heat, use of that heat for certain purpose, then conversion of heat or certain conversion of any other energy into the heat or heat into any other form of energy, and exchange of that heat or the thermal energy between the physical systems. Okay, now we have studied in the previous classes that what are the different mode of the heat transfer, basic mode of heat transfer, that is conduction, convection and radiation. Can anybody please tell me what is meant by conduction is? Yes, anybody? What is meant by conduction?
Transfer of
When
heat in material.
transfer of heat in material, there will be a transfer of heat into convection also, and that will also be in a physical system, that means in a material, certain material, right? So when you can
Transfer of heat by
Transfer of
material
internal energy.
molecules, electrons.
by motion
Man,
of,
through direct contact. Transfer of heat through direct contact.
yes, you can say in that way, that is the transfer of heat by direct contact. What is meant by convection? That will also be actually the direct contact. But what is the difference between conduction and convection?
In conduction, electrons movement is completely. I mean,
No.
conduction difference in temperature
Okay, and दोनों में temperature
and
difference है.
no, no, convection में difference in density.
Okay, motion is due to difference in density, and in the conduction is due to the difference in the
Difference in
temperature.
temperature.
Fine. And then what is meant by radiation?
Um,
Electromagnetic waves.
great
Okay,
temperature will greater than uh,
okay. So
temperature बढ़ेगा.
yes, of course, temperature will increase. But what is meant by the radiation? Temperature is of course
Transfer of heat
different or
through
increasing
rays.
in the conduction and convection also. But then what is difference in the radiation?
Ma'am, transfer of heat due to electromagnetic radiation.
Correct. Electromagnetic wave. So that is known as the radiation. Okay. So let's take an example. Just a minute. I'll show you a diagram. Okay. So let's take an example. Let's say this is the body number A and his body number B. Okay. And now let's understand what is meant by conduction. Okay. So let's say this body A is having this ball, okay, this black dot as a ball, okay, and that A wants to transfer that towards the B. Now, how he can transfer? Okay, so for that, let's say he has arranged number of persons in between this. Okay, so let's say this is person number C, D, E, F, G, H, I, J, K. Likewise, number of person are there who are standing in between them. Then what they are doing? They are passing that heat from one to another, one to another, one to another without motion of their own. Okay, so this is how, if the heat is going to transfer, you can say it as a conduction mode. Okay, that means heat is transferring from person to person. So in a body, atom is the one, okay, atom is the one, and they are having their own motion, random motion. So due to their motion, what is going to happen? It is going to transfer from one atom to the another atom just due to a direct contact. That means, let's say this is atom number 1 and this is atom number 2. They are having their own random motion. When they collide with each other, it will transfer the heat toward this one. Then when it will collide with this one, it will transfer the heat to the this one. Okay, so this mode is known as the conduction mode. Second one is the convection. Now here, instead of number of person, let's say here is person number C. Okay, so what the person number A will do? He will give its heat to the, or give the ball to C, and then then C will move along with this heat to this B. So that means C has to travel towards B. Okay, there is no intermediate other person is available. Okay, so what is going to happen over here? That person is going to move along with that heat and going to give that heat to the B. Okay, so this type of mode is known as the convection. That means here the person is going to move as well as heat is also going to move. In the conduction, the person are not going to move. They are only transferring or sending it to the adjacent one. Okay, while here when A has given the heat to this C, that will move with it and then give the heat to the B. So this is how you can transfer it from A to B, and that is the mode is known as the convection. While third one is the radiation. Now in the radiation, no other person is available over here. So what A will do? A will throw it directly and B will catch it. Okay, so no media is required over here. So that is known as the radiation. Okay, so in the conduction, let's say you are having a rod, a bigger rod, and this rod is made of number of small atom. Okay, number of small atoms. So what will happen over here? Let's say here you are having temperature T1 and here temperature T2. Okay, T1 is greater than T2. Okay, so what will happen? This this A and this other atom both are having some random motion. So they will collide together and heat will be transferred to this atom. Now this atom and this atom, they are also having random motion. Okay, so this atom will transfer the heat toward this one. Then again these are having the random motion and the heat will be transferred to this one. Okay, due to the direct contact of the atom to atom, what is going to happen here? The heat is going to transfer. Okay, so that is known as the conduction. Okay, and now in a convection, instead of a rod, let's say this is having a liquid. Okay, this is the liquid. This is liquid. So now liquid molecule, they are having more tendency to move. Randomness is more, entropy is more as compared to solid. So what will happen here? So what will happen here? The heat will be transferred, okay, because of the motion of this A towards B. A is going to move and transferring the heat to the B. Okay, so that is what is the convection. And what is meant by conduction? Conduction, there is no media at all, no media required at all. There can be media, but in radiation, no requirement of media is there. So the heat will be directly transferred from A to B. Okay, so this is what is the radiation is. Hopefully you have understood the concept.
Yes, ma'am.
Okay. Now, for these three modes, there are certain laws. For conduction, the law is Fourier's law of conduction. For convection, the law is Newton's law of cooling. And for radiation, the law is Stephen Boltzmann law. Okay, so now why these laws are required? Because we must understand how much heat has been transferred. Okay, so what this Fourier's law will say, it states that the time rate of heat transfer through the material is proportional to the negative gradient in the temperature and to area and inversely proportional to the length of the path of flow. Okay, so let's understand once again through a diagram. Now, let's say we are having this block. Okay, yeah, something like we are having a block, and this is the length of the block, let's say dx. Okay, this is the area A. Here is, let's say, temperature T1, and on the back side the temperature is T2. So what will happen? Let's say heat is going to transfer in this direction, right? So what is going to happen? This heat transfer rate, it will be dependent on this area. Okay, it will be dependent on this area because number of molecules are more. Okay, if the number of molecules are more area will be transferred. Okay, sorry, more heat transfer will be there. Okay, if the area is small, less number of molecule will be there. Okay, then that means less heat will be transferred. So you can see from here that Q, or the heat transfer, it is directly proportional to the area. First thing. Okay, then further you can see whatever the difference in the temperature, that also matters a lot. Okay, if the temperature difference is more, then again the heat transfer will be more. Let's say other example, you are having a hot cup of tea. Okay, you are having a hot cup of tea. That cup of tea, let's say it is having a temperature of 100 degrees Celsius, and there is another cup of tea which is having the temperature of 50 degrees Celsius. Okay, so you which in which the heat transfer will be more? The one which is having the higher temperature, because the temperature of
Yes.
the cup, difference between the temperature of the cup and the atmospheric temperature, okay, it is very high as compared to the other one. So what will happen? It will have more tendency to transfer the heat. That means from here you will understand that Q is, again, it is directly proportional to the change in the temperature or difference in the temperature. Okay, that is delta T. Okay, now another thing, you will see here, when the heat is going to transfer through, let's say, this slab, the heat which has been transferred, let's up to this limit, okay, it will be more. Okay, the shorter the distance, more the heat transfer will be there. Okay, if you are increasing the thickness of this slab further, you will find that at this end the heat transfer rate will reduces. So from here you can say that Q is inversely proportional to the length, that is dx. Let's say dx is the length. Okay, so this is what is the Fourier's law is. What it is saying, that heat transfer rate is directly proportional to the area, okay, perpendicular area, and temperature difference or temperature gradient, and inversely proportional to the length along which the heat is going to transfer. But also in the same law you will find here that it is saying that negative gradient. Now what is meant by negative gradient? See, we know very well that temperature is always going to transfer from hot body to the cold body. Okay, that is what is the second law. Is the second law of thermodynamics is that it is impossible to transfer the heat from lower body to the hotter body. That means always the heat will transfer from hotter body to the colder body. Okay, so unless and until you will supply certain external work, then and only then you can do the reverse thing. Okay, now what is going to happen here? The temperature, whatever the temperature is, okay, the temperature is uh, heat is transferring from high temperature to the low temperature. That means in a negative direction. That's why it is saying the negative gradient. Okay. So this is what is the Fourier's law. That is time rate of heat transfer. Heat transfer rate. That means heat transfer rate through the material is proportional to negative gradient in a temperature. Okay, negative gradient in a temperature and to the area, and inversely proportional to the length of the path of the flow. So you can write it as mathematically Qx is directly proportional to the area dt, okay, divided by dx, that is the length, okay, smaller length. And if we remove this constant of proportionality, we can write that if we remove this proportionality sign, we can write it as by giving this constant of proportionality, that is k. And why this minus sign? Because of this negative gradient. Okay, so what your formula will become, that is Qx is equal to minus Ka dt by dx. Now you can take this area on the other side and that will give you the heat flux. Okay, so Qx is a heat transfer rate. While if you divide it by the area, that term will also known as the heat flux. Okay, so heat flux is equal to minus K dt by dx, where Qx is a heat flow rate, Qx by A is a heat flux, K is the thermal conductivity of the body, okay, and area is the cross-sectional area perpendicular to the direction of the flow of the heat, and this x is the distance, okay, or the length of that particular body, okay. Now, you can see here thermal conductivity, this K. It is again different for different body. Higher the number, higher will be the capacity of that body to conduct the heat from one point to the another point. Okay, copper is having very high conductivity, so the K will be bigger one. Okay, water, it is having less as compared to the that copper. Okay, air again lesser than that. So this is what basically K denotes, that is how much capacity it is having to conduct the heat from one point to the another point. Okay, so this is the law which is applicable for the conduction process. Next one is the Newton's law of cooling. Now what Newton's law of cooling is saying, that the rate of heat loss of a body is proportional to the difference in temperature between the body and its surrounding while under the effect of the breeze. The constant of proportionality is a heat transfer coefficient. So it is kind of similar thing, but this convection is, it depends on the difference in the temperature of the two bodies between which the convection is going on, and it is directly proportional to the area. Okay, and you can, if you replace the constant of proportionality sign, you have to keep the constant, that is h, and this h is known as a heat transfer coefficient. Okay, let's say if we are having a fluid, let's say water is there, and let's say we are having an object. Okay, let's say we are having a hot ball, metal ball, and if we put it inside that water, so what will happen, the water inside that water, the convection will start, convection process will start. Okay, now that convection, whatever the heat which is going to transfer in that water, that heat transfer rate, okay, that heat transfer rate, it will be equal to the area of that object, that means area, surface area of that ball. Okay, because jitna bada ball hoga, the more area will be available with you, that means more heat transfer will be there in the water, toward the water. Okay, so the area of that ball is very important, that's why it is directly proportional to the area. Second thing, let's say we are having two different balls, one is at 300 degrees Celsius, another is having at 100 degrees Celsius, and water is having the same temperature. Let's say water is having the same temperature. So what will happen here? The hotter the ball, more heat transfer will be there, right? That means difference is because of
Ma'am,
that
I think you are not audible.
difference. Yes. Hello. Hello.
Yes, ma'am.
What is happening? Am I audible properly?
Yes, ma'am, you are audible.
Yes, ma'am.
Yes, ma'am.
Okay. So the as the ball which is at 100 degrees Celsius, okay, and it is placed in the water which is around at 25 degrees Celsius. So the temperature difference is more in that case as compared to the ball which is at 100 degrees Celsius and placed in the water which is at 25 degrees Celsius. So definitely what will happen, the heat transfer rate will be more in the first case because the temperature difference is more, right? So that's why we can write that heat transfer rate, it is equal to heat transfer coefficient, that means H, okay, into area into difference in the temperature of the two bodies or two objects, which is or you can say object and the body of temperature of the fluid. Okay, now heat transfer coefficient, it is again different for different fluids. Air is having different heat transfer coefficient, water is having different heat transfer coefficient. Okay, and if we want to find the unit for H, that will be equal to, this is in a watt, okay, this is in a watt, okay, this is in Kelvin, okay, this is in Kelvin, and this is in meter square. So the unit for H will be watt per meter square Kelvin. Okay, watt per meter square Kelvin. While here this K, if we talk about this K, okay, if we want to find the unit for this, you can see here Q is in watt, this A is in meter square, this is in Kelvin, and this is in meter. So if we take everything on the other side, you will get that unit for the K will be watt per meter Kelvin. Okay, this is what the difference between H and K. This is per meter and this is per meter square. Okay, now this is related to the convection. Now when there is a radiation, you are supposed to follow the Stephen Boltzmann law. Now what the Stephen Boltzmann law says? This Stephen Boltzmann law basically talks about the black body. Now, what is the black body is? Black body is the one which is going to radiate continuously, okay, and maximum amount of the heat from it. So, Boltzmann law says that total power per unit surface area that is radiated by an object often to be a black body. Okay, that means जो सबसे ज़्यादा
Ma'am,
जो power, yes,
what happened? Actually, you're not audible in between.
Harsh, please check your mic. I think I'm audible to everyone else.
Yes, ma'am,
Ma'am,
you're
now it's
audible.
audible.
Yes, ma'am. We
Yes, ma'am.
properly
Now it's
audible.
audible.
Yeah. Okay, so what the Stephen law says that total power per unit surface of the area, okay, with that is radiated by the object often to be a black body. So it is talking only about the black body. That is when whatever the heat transfer will be there, okay, per unit area for that black body, it is directly proportional to fourth power of its temperature. Okay, for example, let's say sun is there. Sun is a kind of a black body. Okay, it is considered as a black body. So how much it is going to radiate the heat? Okay, so that for that, what you can do, you are supposed to proportionate it to its temperature to the power of 4. Okay, so that is what basically Stephen Boltzmann law say. Now, but now here you can say that it is talking only about the black body. So, and in the practical thing, black body is we can say it as a hypothetical one. So each body is having their own capability to emit to radiate. Okay, and that can be denoted by the emissivity. Okay, that can be denoted by the emissivity. So you can say that emissive power of the body or heat transfer rate per unit area of the body is directly proportional to the emissivity to multiply by fourth power of the temperature. Now, if we want to remove this proportionality sign, we are supposed to multiply it by the Stephen Boltzmann constant, which is denoted by the sigma, and its value is equal to 5.67 into 10 raised to minus 8. So, for any body, if you want to find the heat transfer rate per unit area, this is heat transfer rate per unit area. Okay, previously we have seen only the heat transfer rate. Here it is heat transfer rate per unit area. It is equal to sigma epsilon T raised to 4. That means Stephen-Boltzmann constant multiplied by emissivity of that body multiplied by surface temperature to the power of 4. So this will give you the radiation, how much radiation has been is carried out over there. Okay, so these are the three laws which are very important when we are talking about the heat transfer, because we know that there are three different modes of heat transfer: conduction, convection and radiation. So whenever you are having any certain case in front of you, so you must understand what type of heat transfer is going on over there. Okay, once you will find out what type of heat transfer is going over there, from that you can find the certain heat transfer rate by using these three laws. Okay, so now let's move to the numerical. Let's take the first numerical. Okay, so here is your first numerical. Before going to the first numerical, let me write down the formulae over here so that it will be quite easy for you to grasp. Okay, so this is for conduction, and here it is for convection, and the last one is for radiation. Okay. T to the power of 4. Okay, so these are the three equations for conduction, convection and radiation. So now here you can see there is a question that is a plain wall 15 centimeter thick. Okay, so there is a wall. Let's say this is a wall. Its thickness is given as 15 centimeter. So you can see this is given as 15 centimeter. Okay, so this is 15 centimeter. Okay, and cross section area is 5 meters square. So this area is given as 5 meters square. Okay, thermal conductivity is given as 9.5, and inner and outer surface temperature is given as 150 and 50 degrees Celsius. So here the temperature is 150, and on the back side the temperature is 50. Okay, so here given is, what is given? Length is given as 15 centimeter. Area is given as 5 meters square. Okay, then conductivity is given as K is 9.5. T1 temperature is given as 150 degrees Celsius, and T2 is given as 50 degrees Celsius. Okay, now what is asked here? Determine heat flow rate. Okay, so first you are supposed to find the heat flow rate. Now what is mean by heat flow rate? Q or Q by A?
Q.
Q. Okay, so here you can see as conduction is given over here. That means you are supposed to use this first formula. Okay, so that means Q is equal to Ka dt by dx. So everything is given to you. K is given to you as 9.5. Area is given as 5 meters square. dt, that means difference in temperature you are supposed to take. And dx. dx means this 15 centimeter. Now always remember that this is given in a centimeter. You are supposed to convert it in meter. And then find the value of Q. Tell me how much is the Q?
3.16 watt.
3.16.
16 watt.
Okay, 3.16 watt. Okay, now next one is the heat flux. What is meant by heat flux now?
Q by A.
Q by A. Q by A. Right? Q by A. And that means you are supposed to simply take this as 3.16 divided by 5. That will give you Q by A. Right? Everybody, please let me know whether you are getting the same answer or not.
$63.
63.
Ma'am, Q 3.16 वाला.
63.33.
How much is the Q? Is this correct?
6.32 आ रहा है मैम.
6.32.
नहीं, एक मिनट. 0.63 आ रहा है.
No.
वो Q by A.
I think this is also wrong. .5 into 5 into 100, that is the temperature difference, divided by dx, that means 0.15. So as for me, the answer will be 31.66 kilowatt. Please check. This may happen that I may make mistake, but please check.
Yes, ma'am. 31.6 kilowatt.
31.66 kilowatt. Now tell me what is Q by A? Heat flux.
मैम
6.3.
6.332.
6.33 kilowatt. Okay, 22 is also fine. Okay, so this is how basically you are supposed to solve the problem for the conduction. Okay, next one is a convection. Okay, now you are supposed to use these formulas again. Okay, so now what is given? Let's see. Consider a hot plate of area 2 meters square. So what is given? The area is given here, that is area is equal to 2 meters square. Okay, it is maintained at 250 degrees Celsius. That means temperature, first temperature is given to you for that body is 250 degrees Celsius. Okay, the plate loses heat over its surface both in the form of conduction, so convection and radiation. That means here you will find that both two ways are actually, two modes are going to be used to lose the heat, convection as well as radiation. Okay, if the temperature of the surrounding air is 25 degrees Celsius, that means T2 is given as 25 degrees Celsius with a coefficient of convection. Coefficient of convection is denoted by H, right? So it is 20 watt per meter square Kelvin. Okay, and heat loss due to the radiation is given as 200. So here you can see directly QR, matlab radiation, heat loss due to radiation is directly given. You are not supposed to calculate it. Okay, directly that is given. But what is asked? What is the net rate of heat loss? That means first you are supposed to find the heat loss by convection. Now for convection, the formula used is HA into change in the temperature, the difference in the temperature. Okay, so H is given to you. Okay, area is given to you, and two temperatures are also known to you. So simply put and tell me the answer. What is the QC? And after that, add it with the QR and tell me the net heat transfer or heat lost. So how much is the QC? Yes,
9,000.
correct. 9,000 watt. 9,000 क्या? Unit? Watt or
Watt.
kilowatt? Watt.
Watt.
9,000 watts.
9,000 watt. And net is 9,200 watt. Right? Let's move to the next one then. This is the simplest one.
Ma'am, with
Yes?
QR 9,200, na?
Yes. QN.
Yes, QN.
Okay?
Ma'am, QN means?
QN means net heat lost. Here you can see what it is saying. Heat loss is by convection as well as radiation. So you are supposed to add this as well as this. Okay, that is what the net. Net
Okay.
means total. Okay?
QN is equal to QC plus QR. ऐसा ही है.
Yes. QN is equal to
QC plus QR.
QC plus QR. QC plus QR. Okay?
Yes.
Now last one is this one. Calculate the heat flux at the surface of the sun. Its surface temperature is 5,900 Kelvin. Okay, so now that means directly temperature is given to you. Okay, 5,900 Kelvin, and that is also directly given in the Kelvin, so no need to convert it. Okay, so now find the heat flux, that means Q by A. How you can do that? How you can do that? It is directly proportional to the temperature, fourth power of the temperature. So it will be equal to epsilon. Epsilon is how much? Sorry, sigma. Sigma is how much? 5.67
5.67 into 10
raised to minus 8 multiply by T raised to power 4, because sun is now considered as a black body. Okay, so T, that means, sorry, 5,900
Power 4.
to the power of 4. Okay, tell me.
The 10 raised to minus 8.
Sorry,
10 raised to minus 8.
10 raised to minus. Tell me the answer now.
Ma'am, 6.87054 into 10 raised to minus 8 ऐसा आ रहा.
Correct.
Yes, ma'am.
Okay, so this is how basically you are supposed to solve this numerical. So just